Yeah, hi and welcome to Introduction to Structured Programming. I hope you can hear us also in the last row. Maybe you can give us a quick sign if it works, if you can hear us in the last row. A bit louder, okay. Maybe it's better now. Yeah, it's working, perfect. Yeah.
Hi, also from my side. I hope you can also hear me back there. Thank you.
Perfect, yeah. Nice to see all of you, so many of you in the lecture hall today. So not only in the stream, in the chat, but yeah, here in person. And we are already in week 4, so almost 1/3 of the lecture. And today we will mainly talk about arrays, but it's not only arrays. We'll also have few operators. Also, yeah, as Julia and Michael just mentioned before in the practicals, also some design of the code to write beautiful code and more understandable code. But before we start with the content, as always, we have a few organizational matters. The first one is assignment 1. So assignment 1 is due by next Wednesday, 6 p.m. Make sure to commit and push all your changes in time. So yeah, always makes sense to have a bit of a buffer, a few minutes at least. Do not commit and push at 6 p.m. There might be any technical problems, so please do it early enough. Yeah, the submission is via your GitLab repository that was assigned to you already or will be assigned to you very soon. And we will also announce further information on the assignment interviews, which will take place after the deadline. And we also want to mention the question hour that will take place next Monday in the lecture hall I3. It's Monday on the 27th of October. It's from 2 to 4 p.m. And you don't need to register or do anything. You just can come there in the lecture hall. So please use this opportunity to ask questions. And there will also be some, presentation before that. All right, then we have the weekly exercises. So we have already released all weekly exercises that are related to assignment 1. These are in total 10 exercises. And today we will hand out the first weekly exercises that are related to assignment 2 already. But don't forget to work and submit the weekly exercises for A1. Otherwise, if you have less than 50% of the weekly exercises for assignment 1, you will get a deduction of 25%. So make sure to do them in time until next Wednesday.
Okay, yeah, so let's continue with a short recap of last week's lecture. And to do so, we have prepared a few Slido quizzes for you. So please, read carefully and mark all the correct statements regarding functions, and use the QR code or the code on the bottom left side for entering it on slido.com to attend this quiz.
Yeah, so last week we mainly talked about functions, so decomposition of huge problems into subproblems, as we've just seen before in the practicals. There are a few cases where you should everything put into the main function, but there are many, or I think most of the time, you should split up your code into different functions that have exactly one functionality. This makes the code more readable, but also it's easier to maintain if you split up your code into multiple functions with exactly one functionality. Yeah, we also had a look at how functions should be written. So what are parts of a function header? What can be passed to a function? It's the function body.
Yeah, also the return statements.
Okay, we we've already got 50 responses. Let's wait a few more seconds. Yeah, maybe we can reach 100 and then...
Okay, let's wait for 100.
Yeah.
Few more seconds, hopefully.
One more.
Yeah. So now we've passed 100. So let's have a look at your answers. Yeah, and most of you got the 2 correct answers right. So the first one is that the return value must match the return data type in the function header. If this is not the case, the compiler would give us an error. So the program would not compile if this is not the case. A function can have multiple return statements, but only one will be executed. Why is this true, and why is there only one of the return statements executed?
We can have multiple return statements, so that's totally fine. But once we reach the first return statement that is executed, no code below that or after that is executed anymore, because we return to the function that called the function we just returned something.
Yeah.
So there can be multiple, but only the first one that is executed is really executed. All the other return statements are not executed anymore.
Okay. Yeah, and the other 3 answers were incorrect, as most of you spotted right.
Perfect.
Okay, then let's have a look at another Slido quiz where we have provided you a short code snippet, and one part of the code is not visible yet, and you have to insert the correct code statement so that the code finally is printing 18. You can choose from a few different code statements. Please choose the correct one so that 18 is printed eventually. I think we reached the 100 mark a bit faster now.
Yeah.
Not so much to read as before.
Okay, maybe let's wait a few more seconds.
Yes.
And then... Okay, then let's take a look.
Yeah, most of you got it right. So the correct statement is int sum. So we declare an integer variable called sum, and we call the function add and pass a and b, so the values of a and b. And if we have a look again at the code, then we see that we pass the values 7 and 11 to the function add, and then the return statement of a plus b, meaning 7 plus 11 is 18, is returned and stored in the sum variable, and this value is finally printed. Okay.
Maybe we're going to take a look at the second option. So in sum is add a plus 2.
Yeah.
Why doesn't this work? Or why
yeah, what would happen in this case? So if we use a plus instead of a comma in this case, when we call our add function, the compiler would have a problem with that, because with this a plus b, this would be an arithmetic operation where we add 7 and 11 already here. So we would pass 18, just one value, just 18 to the function add. But the function add needs to get 2 values, a and b. And therefore, the compiler would say this is not possible. This is an error because we just pass one argument and not two as the function would need. Okay, and the third and final quiz for the recap is again a code snippet. Again, a code part is missing, a statement is missing, and please choose the correct statement so that the code finally prints 20.
So yeah, this is interesting because we only have one statement that is missing, and we want to find the maximum of two numbers.
Yeah, so obviously we have to compute the maximum of two integers in one statement and also, yeah, give the value back to the main function somehow.
Okay, a few more seconds.
Yeah, again, most of you got it right. So the correct statement is return then a comparison of A and B, so whether A is larger or greater than B. And if this is the case, we return A, and otherwise we return B. So we use this ternary operator here with this question mark and the colon in this case to have a very compact form of this maximum calculation, and yeah, a one-liner with the return statement, which is quite nice. Yeah.
What would happen if we would write return max A and B? So let's take a look again at the code snippet.
If we would have taken the second answer that we return the result of another call of max with A and B, this would then result in a recursive call. So the max function would eventually call itself again, and then it would call itself again, and so on and so forth. And we do not have any break condition to break this infinite call of max. So then our program would run until our memory is out of error.
So since we don't have specified any base case, we would just call it again and again and again, and at some point we would probably run out of memory, the program crashes, and eventually we do not have the maximum number, unfortunately. All right. Yeah, but very good results so far. And we will again start with operators. So we've covered already most of the operators that we're interested in. So arithmetic operators, comparison operators, logical operators, unary operators. And today we will take a look at two more families of operators. And the first one is the modulus operator. Halloween is just around the corner. It's a bit more than 1 week. And of course, we want to provide some candies for all our friends that will come and visit us. In this case, we've got 3 friends and we've got 10 candies. And we want to share or give our friends the candies and distribute it equally. And maybe there are some candies that we can keep, we can eat.
But how many?
That's the question. That's what we want to compute. So we want to give all of our friends each 3 candies. And we want to know, okay, how many will be left over? How many can we keep and eat, hopefully? In this case, we can probably clearly see it that it's just 1 candy that will remain. We call it remainder. And this is the one that we can keep. because we gave all of our friends equally free candies. But since we have 10 candies and we have 3 friends, each of them giving 3 candies, there will be one that is left over. So we can either go through it, think about it, but we can also use an operator that is not only used in the C programming language, but in many other programming languages. It's quite useful. There are many use cases. We will see it in a few slides. And the sign that we use for the Modulus operator is the percent sign. Maybe some of you have already seen the percent sign in the weekly exercises. So there's one exercise where you should or have to use the Modulus operator because it's already given in the code. And what happens when you use the Modulus operator is that you get the remainder of an division of 2 integers. So you could divide 10 by 3, which is 3 times 3, so you would get the result of 3. But you want to know the remainder in this case, and using the Modulus operator, you would get 1 as a result. So you could, for example, store the result of this expression, then modulus 3, in another variable and can work with the remainder stored in a variable. So that's quite useful and helpful in many cases. And now we want to know, if you have any ideas, any suggestions, what is the result of 9 modulus 2? Is there any suggestion? Yeah. Yes. So the remainder is 1. Why? Exactly. Yeah, that's the correct explanation. So we know 2 times 4 is 8. Okay. And we know plus 1 is 9. So we have 1 as a remainder. And this not only works for 3 and 2. Of course, we can use any number for the calculation of the remainder. Here are just a few examples. So these are just a few use cases where it's very helpful and very useful to use the modulus operator. I think the prime example is the even and odd check. So if you have to check if a number is even or odd, so in German it's gerade oder ungerade, then you can just use the modulus operator, compare, or let's say number modulus 2 is equal 0. If this is the case, you know, okay, the number will always be even. And if this is not the case, either you just use an else here or you have the statement if number modulus 2 equals 1, then you know, okay, the number is an odd number. But even an odd check is not the only use case that we can or that we have for the modulus operator. We can also do something every 5th iteration, every nth iteration. So if we have a for loop, for example, we can say, okay, I want to print something every 5th iteration. So when we have reached 5 iterations in the loop, then we print here 5 more iterations. And this is done every 5th operation because we use the modulus operator and say, okay, if the remainder of the current index, modulus 5, is 0, then we reach the 5th iteration again and we print something or do something else. But it's also quite useful if we want to stay within a specific range of values. Let's assume we have the weekdays, which are numbered from 0 to 6. Let's say 0 is Monday, Sunday is 6. And of course, if we have weekdays, we don't want to reach the number 7 because it doesn't exist if we only have 0 to 6. And we don't want to have any negative numbers, for example. And with the modulus operator, we can say, okay, we have some old day, can be any number. We increase that by 1. And using the modulus operator, if we, for example, reach the 7, this will result in a new day, which is 1 and not 7. So we can only stay in this range of values that we have defined using the modulus operator. Weekdays is just one example, there might be many more examples, probably also during assignments or weekly exercises. Are there any questions regarding the modulus operators so far? If this is not the case, then we will come to the second bitwise, to the second operator, which is the bitwise operator. We will just discuss it briefly because we will not use it very much, but in your future studies or other courses, you will probably need the bitwise operators. Yeah, I think the name suggests already that bitwise operators work on bit level, so you perform some operation, can be different operation, bit by bit. So you don't perform the operation number by number, for example 12 and 10, but you really enter the bit level here. So this is just the binary representation of 12. The binary representation contains only digits 0 and 1. And with this representation, so one digit here is called bit, we can now do some operation on this level here. So we don't consider that 12 anymore as integer in this case, but we consider bit by bit of the original value that we have. And there are a few operations that are interesting for us. For example, we can perform a bitwise AND. This means that we compare, let's say, the rightmost bit of the first number with the rightmost bit of the second number, perform the AND operation. So we know that 0 and 0 is 0, 0 and 1 is again 0, 1 and 0 is 0, but 1 and 1 is 1. So we can go through it. We see, okay, 0 and 0 is 0, 1 and 0, again 0, 0 and 1, 0. Okay, now we have 1 and 1. This will result in 1. And here we only have 0, so all of the bits here are 0. So this is the bitwise AND operation of two numbers.
So then the final result of this bit operation would be that the integer c would get the value 8, right?
Exactly, yeah. So again, when we go from the binary representation into the decimal representation in this case, we would then have the value 8 that is stored in the variable c. Exactly. Yeah, we cannot only have the bitwise AND, we also have the bitwise OR in C. It's similar to the AND, except that the case 1 and 0 results in 1, and 0 and 1 results in 1. So we have 0 and 0 is again 0, 1 and 0 is 1, 0 and 1 is 1, 1 and 1 is 1, and again we have zeros on the left side, so this again will result in 4 zeros. And of course we can again store it in a variable, again when we do not represent it as a binary number, but as a decimal number, we would get the value 14 here if we have a bitwise OR of A and B. Then there's also XOR. The rules for XOR are that only one of the 2 bits can be 1, and only if this is the case, then the result is 1. So we have 0 and 0, which is 0. We have 1 and 0, which is 1. We have 0 and 1, which is again 1. And now we have the case that 1 and 1 is 0, because only one of the 2 numbers or the 2 digits are allowed to be 1. Otherwise, the result is 0. And yeah, we can again store it in a variable, and as a decimal number, this would then be 6. We can also do a not operation on one number. So, for example, we take 12, again, having the binary representation, and now if one digit is 0, we translate it into 1, and if the digit is 1, we then get 0. So we just use the opposite digit. So for 0, we have 1, for 0, we have 1, for 1, we have 0, for 1, we have 0, and here the remaining zeros are 1 if we use the bitwise not operation. Again, we can store it in a variable and can use it for further computation. And the last operation that we're interested in is the bit shift. So we can shift all of our bits either to the left side or to the right side. What happens here is that we, for example here, shift all the bits to the left for the variable a. So we add a 0 for the rightmost bit. So we have to shift it to the left. Then we see, okay, this first 0 here is now the second 0. The second 0 from the original number is the third 0. Then we have the first 1 in the variable that we have at position 3 is now at position 4. And the fourth digit, which is again a 1, is now at position 5. And the remaining zeros are just shifted to the left. What's very cool with using bit shifts is that we can multiply a number by the powers of 2 or divide it by the powers of 2. So if, for example, we have 12 here and we shift it by 1 position to the left, this means that we multiply this number by 2 in this case, so 2 to the power of 1. If we would have a bit shift by 2 to the left, we would multiply this number by 2 to the power of 2, so we would have 12 times 4. And yeah, the same thing for the other direction. So if we shift all the bits to the right, this means we divide the number by the power of by 2 to the power of 1 if we have 1 shift to the right, and so on and so forth. If we shift it, for example, by 2, we have 12 divided by 2 to the power of 2, and so on.
Yeah. Do you have any use cases for such bit operators?
Yes, we have a few. Bitwise operators are particularly useful if you program on a system level, if you program on microcontrollers, so if you're close to the hardware, but you can also use it, for example, in the network technology. If you, for example, have IP addresses, they're quite useful and helpful, but also for some performance optimization. So there are quite a lot of use cases, but you will probably work with them then more in other courses. All right, then since we have now already covered a lot of operators that exist in C, the C programming language, let's take a brief look at the operator precedence and associativity. So in total, we have 15 levels of precedence. You don't have to know every level of precedence, all the operators, and also the associativity by heart, at least for now. You will get to know most of them by just writing code, and then you will see, okay, this has a higher precedence than another operator, but just that you know that there are in total 15 levels of precedence, and that there's also a different associativity depending on the level and the operators that you use. So we have listed all of the operators that exist. Maybe particularly interesting is the comma here. So you can have multiple expressions in one statement that is separated by a comma, and yeah, as we would assume, this has the lowest precedence. So this is the operator that is considered at the last point.
Yeah, maybe we can here recap one example from the practicals before. So there we have seen that we have we had a comparison for equality and also an assignment operator in one line, if you remember. And yeah, we can see clearly that the comparison operator is executed first and afterwards the assignment operator.
Yeah, so you will probably face some issues that is related to operator precedence. Also happens to me from time to time. But yeah, taking a look at this table would definitely help you to get rid of such issues. Okay, then let's continue with a code snippet that is not really beautiful, in my opinion at least. Maybe some of you have seen such a kind of code snippet with a lot of nested, in this case, if statements and blocks. So this is not really beautiful and readable. Yeah, let's think about one example where this could occur is that we have a function which receives some points, can be or should be between 0 and 100. And depending on the points, we want to print the name of the grade the student, for example, will get. Yeah, what we could do is that we have a first condition that will check if the points that we have received is in the range that is valid. So for example, if the points are actually between 0 and 100. And if this is not the case, we just print, okay, no, this is the wrong range, and return -1. Okay, it looks fine, works, so why we don't do it like that? But if we now want to really distinguish between the grades that the student will get, we would have to perform multiple checks. For example, if the points are or lead to an excellent grade, which is larger than 88 points, or if it's just a good with more than 75 points, or more than 62 points, which would be a satisfactory, or if the points are enough for a sufficient grade, or if it's even insufficient. Yeah, this looks quite similar to the code snippet that we have seen just before. It's not beautiful, not readable.
It somehow makes sense as you explained it, but as you see, the more cases you add here, the worse it gets and harder it gets to read.
So if we would change something at this if here, for example, it would be terrible if there would be a bug that we have added. So yeah, it works, but it's definitely not beautiful and not easy to maintain. So what could we do? We could think about using a guard clause, which just means we have an integrity check of a precondition. In this case, the precondition that we have is that we want to check if the number is between 0 and 100, because if this is not the case, the grade is not valid anyhow. So we can just throw it away. We don't have to consider any other possible grades this point could lead to. And using guard clauses can simplify these complex, or at least not beautiful, blocks of code. And we will now take a look at it, how we could add a guard clause here and make the code more readable. So instead of having the first condition, which checks if the points are greater than 0 or less than 100, we could do the opposite. We could just check if the numbers are less than 0 or if the numbers are, or the points are greater than 100, because if this is the case, we know the valid is not great, and we can just say, okay, this is the wrong range, and return -1. And with this condition, we can consider any other case. So if this expression here evaluates to false, we know, okay, the user input, the points for the student are valid. And this is a valid user input. So we can now add another condition which says, okay, points is larger than 88. This is excellent. And we could do the same for the good, which says points larger than 75. We could do the same thing for the satisfactory, add another if block. We could do this also for the sufficient if the points are larger than 50. And eventually, we would then have this code snippet here, which is, in my opinion, hope also in your opinion, a much more readable, easier to read, and we got rid of all the nested if blocks here, which are terrible to read and to debug if there are any bugs in it. And we have now removed all the nested if blocks and have just a list or a sequence of if blocks instead of, in this case, 4 layers in one if.
Yeah. And if we compare those two code snippets, we can also see that we got rid of all the else statements. So why is that?
Because we return here already if we reach one, or if the condition of one of these if blocks is true. So we don't have to consider an else anymore, because once we reach these statements here, so once we reach, for example, the points that lead to an excellent, we just print it and return it. And since we return any value here, in this case 0, none of the code that is below that is executed anymore. So we don't need an else anymore.
Great.
Yeah, it's quite cool, quite useful to use. And we have now also another option. So the first option would be to have the precondition at the top of the, in this case, top of the function, which checks if the input is even valid or if it is invalid. But we also could have then a second option. We'll come to that on the next slide, which says that we could have an own function for checking if the user input is valid. And if this is the case, then we will just go through all the grades and then, print the corresponding grade. I think there was a question here. Yes. Yeah. Thank you. Yeah, that's a good point.
Nice spotted, yeah.
Yeah, of course, this is absolutely correct what you said. In this case, this would always evaluate to true because we check if it's larger than 0 and or less than 100, and this is the case all the time. So this would evaluate to true. It's a mistake that we have made on the slide. Thank you. All right, so these are guard clauses. They are very useful, make the code more readable and easier to maintain because you get rid of all the complex nestings that you have, get rid of all the else blocks that you have. So if possible, it definitely makes sense to use guard clauses.
Okay, next larger topic for today is arrays in C. We have already shortly talked about this topic 2 weeks ago because, we needed it as a motivation also for loops to iterate over arrays, and now we want to have a deeper look into this topic. So what was this topic about? Here we have a short example, of an integer array with 4 positions, so with the size of 4, and we can see different integer numbers in here. What we can also see is that the index of the first number always starts with 0 and not with 1. So as it is usual in computer science in general, the index starts with 0 and not with 1. So we have for 4 elements the indexes 0 to 3. So the index of the last element is always 1 below the size of the array. Yeah, and as we can see in such an array, we can store multiple integers in this case because it's an integer array, and therefore we have somehow combined 4 integer variables behind one name. And how does this look in the syntax in C? So we can define an integer array with these square brackets and the size of the integer array, and then numbers has the size of 4, which is a fixed size and can't be changed anymore. And then we can use 4 elements to use similar as variables. As you can see here, we can access them with the specific index of the elements, starting with the first one with 0 and so on and so forth, and we can assign values to it. There's another way to initialize arrays using this initializer, where we use those brackets and also provide the values for all the elements, and therefore we can omit also the size of the array because this is implicitly given here because we provide 4 integers, therefore the size of the array will be 4. We could also enter the size, which could also be larger than the number of values we provide. For example, we could write here 5, but only provide 4 values. Then the 5th and last element would be uninitialized. Then we have a first example of how to use arrays, so and how to access them correctly. So here we have again an array with 4 elements, and we check whether the first element with index 0 has the value 42. If this is correct, then we go into the if block and print correct. Otherwise, we print the number that is on this first position, also accessing it with the index 0. Then, as we can see, the third element with index 2 has the value 11 because we initialized it with this value, and now we want to change this value, and we can do that similar as we do this with variables. So we can just access the array at position 2, so at index 2, which is the third element, then, and we can override this value by passing another or assigning another value to this position. And therefore, we can use each element similar to a simple integer variable.
May I ask one question
Sure.
here? Since you've now easily changed the value of one, or let's say one value in the array, would it be possible to, let's say, assign the value A as a character, for example, or use a float or double? So is it possible to mix different data types in one array? Because we can do this for structs, so we can group together different data types or variables of different data types into one struct. Does this also work for arrays?
So for arrays, we always have to define the data type at first, as we've seen here. So for example, we say at first that this is an array of integers. Here we again say an integer array, and therefore we have the amount of integers as we provide here, 4 for example, in our memory available. And therefore we can't, for example, write
Use a character, for example.
We could use the value that is stored here, and we could interpret it as character, but we can't really store or use it as a character array, or mix the data types. So integers always have just one data type. Arrays always have one data type. So the next example shows us to work with characters now, as you've asked before, but now we have array of just characters and not integer values. So in this case, we define a character array, which is called options and has the number and has the size 4, which we define as a constant here. And we also provide initial values for all the positions A, B, C, D, the different characters. And then we iterate through this array with a for loop, starting with index 0 and always increasing the index until we reach the number of options, which is 4 in our case. So we iterate through the whole array. And what we do in our for loop is we just print the value that is stored on the eth position, on the eth index, starting with 0, then 1, then 2, then 3. And therefore, the output would be that we first print option A, then option B, then C, and then D. So we could use or we can use arrays with other data types, but always one whole array is always of one specific data type, and we can't mix the data type, at least in C. Okay.
Yeah, but now we also want to know how many values we have in one array. So in this case, we do not specify the size of the array explicitly here, but we just use the initializer list. And in this case, we store 5 values of type integer. And we have talked about the size of operator in previous lectures. And we now want to know the size of the array. If we print this, what will be the result? Are there any ideas what the result will be? Yes. 5? Any other opinions? Other suggestions? Yes? 20? Okay.
Completely different now. So we have 5 and we have 20.
You also wanted to...
Compiler error. Okay.
Interesting.
Third option.
Maybe another option? Yes? I'm sorry, 4, because it starts with a 0.
Because the index starts with 0, so 4. Okay, the fourth option now.
Yeah. Yes, one more option. Sorry? Yeah, you wanted to say the same thing? So we...
Okay.
Yeah. That's a good point.
But I think it would be nice in the end to get 5, right? Yeah. Because 5 is the size of the array. But do we get 5?
Unfortunately, if we just use the size of operator and pass or use the size of operator of one integer array variable, we will get 20. We don't get 5 as a result as the size of the integer array, but we get 20. And we've already heard it. This is because there might be some bytes that we need to consider. And we have now prepared something that explains why we get 20 as the result and we don't get 5. This is simply due to the reason because we have an array of data type integer. We know that the data type integer consumes 4 bytes in the memory. And since we now have 5 values of data type integer in our array, the numbers array, we have to multiply the size of the data type in bytes, which is this case for integers, 4 bytes, and we have to multiply 4 times the number of values we store in the array. So we have to calculate 4 times 5 values, which then eventually results in 20 bytes that we get as a result of the size of operator performed on the variable that is an array.
So the size of operator of an array always returns us the number of bytes the whole array needs in our memory.
Exactly, yeah. So that's why it's unfortunately not 5, but in this case 20, because we need 20 bytes to store all the values in our array here in the memory.
But what can we do to obtain 5 so that we can work with this number? Because then we know, yeah, we have, if the size is 5, we can work with 0, 1, 2, 3, and 4 as correct index. How can we do that?
Yeah, that's a good question. And since we already know the total number or the total size of the array in the memory in bytes, and we also know that we can obtain the size of one integer variable that is needed in the memory, which is 4 bytes, we can just say, okay, we have the whole array in the memory with 20 bytes divided by the, in this case, 4 bytes that is required to store an integer in the array, in the memory. And if we divide the total size by the size of one value, we get the number of values. So this is a great option to really get the size, not the size of the array in bytes, but the number of values in one array. So we have to divide the total size of the array by the size of the data type that we have defined and that the values are stored. All right, so eventually we got 5 as a result for the actual length of the array. And now that we have the length of the array, or the size, we can also use this, for example, in for loops. So we can now use this in the condition. We can iterate through an array by previously calculating the length of the array and having now the condition I has to be smaller than array length. And then, for example, we can simply print all the values that are stored in the array. So that's a great option to be used in for loops, but also in while loops to calculate the array length before you actually do the for or while loop. Because then you know dynamically that you can just iterate how many times depends on the number of values on the length, but you can then just iterate through the whole array. Are there any questions to the calculation of the length of one array? Because this is something that you will definitely need in the assignments, also in the weekly exercises. Okay, then just another use case for the length of the array is if you want to search a particular value in the array. For example, we want to search if the value 31 is one position or is one value of the array. And we can again do this by previously calculating the array length, then iterating through the array. So from 0 to array length -1. So we have the condition I must be less than the array length. And in the body of the for loop, we just compare the number or the value of the current iteration with the index. If this is equal to the value that we look for. If this is the case, we just print it, and otherwise we continue with the next iteration. So just one use case, but incredibly helpful to calculate the length of the array before that. Yeah, but it's cool to store values in just one sequence, but what if we have let's say, multidimensional data. Sounds a bit,
Yeah.
yeah.
Let's think of a specific example as we have here. So in this case, we want to store points of a student in an array. So each point represents or each element represents the points of an assignment, for example. And we could do it like this, that we define an integer array and have then the points that we initialize. And then we can iterate through the array and, yeah, for example, print each point by point. But yeah, now let's assume that we do not have just one student, but multiple students. Then we have, yeah, multiple points and multiple students. So this would then result in a two-dimensional array. This could look like this. We then have multiple rows, and each row would represent one student, so student A, B, and C. Again, starting the index with 0, then 1 and 2. And again, we have 4 different elements per row, which represent the points per assignment, starting again with 0, then 1, 2, and 3. And this is not really a new concept, but what we do now is we define our array in that way that we provide a second dimension. So this is an integer array, not only of size 3, but 3 times 4. And then we have not an integer array, but we have an array of integer arrays. So the elements in our array are arrays of integers. Sounds a bit complicated, but if we write it like this, it gets a little bit more clearly because we now see each row separately with the values, each within one separate array. And yeah, so this is the way we can initialize two-dimensional arrays, which is quite nice and quite useful as we've seen in our use case. And then we can do, for example, an iteration over all students and all points for each student. And we do this with a nested for concept. So we use 2 for loops. The outer one for iterating over the students. We use a student counter starting with 0 until we reach 3, so smaller than 3, for 0, 1, and 2. And the inner for loop is for the tasks or the assignments starting with 0, smaller than 4 for our tasks 0, 1, 2, and 3. And within the inner for loop, we then, for example, print the point of the respective student of the respective task. And we do that by accessing the array with the index of the student, starting with 0 in the first case, and the index of the task, also starting with 0, which is then 42 in the first iteration, in the first loop. And then we increase the tasks counter, but the student counter for now stays 0. So the second iteration of the inner for loop is then student counter 0 and tasks counter 1, which is then this value that we print. And so on and so forth. So we print the first line, and then the inner for loop is done, and then we print as a separator for the students this dash value. And afterwards, we increase the student counter from the outer for loop to go to the next student and start again with the tasks 0, 1, 2, and 3, and so on and so forth. And therefore, we obtain the output, all the points for each student. Yeah, so the question now is, how can we, without using a loop, just access the points of a specific student at a specific assignment. So in this case, how can we now access the points of student B at task D? So we do not want to iterate through all the students and print all the points, but just one. We want just to get one specific point, points from one student at one task. So how is this possible? Do you have any suggestions? Yes, please. Okay, so this is for sure the correct answer, thanks. We access the array at index 1 and index 3. So for the first dimension, we use 1 because we want to have student B, which is here at index 1, and the second dimension, which is for the columns, we want to access task D, which is here at index 3. So we want to access 1, 3 to get 45 in the end. So now we've seen how we can iterate through all the points, but also how we can access one specific element of such a two-dimensional array.
Yeah, and same as in one-dimensional array, you can also use these two indices to change a value. So not only to access it, but to change it, to print it, and whatever you want to do with the value.
Okay.
All right, then we also have the variable length array. This was introduced in the C99 standard. It's just a convenient option to not specify the length of the array, so the size of an array at the compile time, but to specify the length of an array at runtime. So for example, here, the user can enter the length of the array, and depending on the user input, we can then specify how many, in this case, numbers we want to store in the array. So the length is not fixed at compile time, but it is variable, as the name suggests. And the length of the array, once you have declared it, will remain the same. So you cannot change the length of the array once you have defined the length, for example, using the statement here.
So the length and also the data type cannot be changed after an array has been declared. But this is a quite nice way for sure, because now we do not need to specify the size of an array, but the user can then specify the size of the array, for example, or the length.
Yes.
Okay, I think what you mean is that we did not specify the size, but we just do this in combination with the initializer. When we provide values for the elements, then we do not need the size, because the size is implicitly given through the number of elements I provide. But in this case, now we do not have any values until then. So we just define the array with a specific length given by the user, and then we, in the for loop, for example, then we initialize the values.
So if we have an initialization list here on the right side, so independent of a variable length array, we don't have to specify the length, because, as you said, it's implicitly given by the number of elements that you have in the initialization list. But in this case, we need the length. All right.
As you might have already spotted, we now come again to a Slido quiz. Again, having a short code snippet, again with one statement missing. Please tick the correct statement so that in the end this code prints 15.
Maybe in the meantime, I have another question regarding 2D arrays. So can we, using the C programming language, only define two-dimensional arrays? Is this the limit, or can we even define, let's say, three-dimensional arrays?
We could go even further, and we are not limited by the dimension of 2, so we could go into further dimensions by just adding another square brackets with size part to have a third dimension, and then we have an array of integer arrays.
Well,
Gets a bit complicated, but for sure it works, and sometimes it makes sense to use a three-dimensional array.
I'm not sure if we have lost the connection since
not the first time today.
Yeah. Anyway,
hopefully Slido works.
Yeah, let's hope. If we now reveal the options. Okay, no, it works. Great. Okay. The connection was restored. Perfect. Most of you got it right. Maybe what's a bit tricky here is that we do not have the curly braces. So we only have one statement after this part here, after this for part. So we have the three parts: initialization, update, condition, and update. And let's say if we only have one statement, we do not explicitly need the curly braces, but we can just write the statement that should be executed directly after the for part. At least in my opinion, sometimes it definitely makes sense, but usually, at least what I do is that I always use the curly braces, even if I only have one statement. But there are for sure cases where this is definitely appropriate.
Mm-hmm. Yeah, and why is the second one not correct? They are quite similar. Yeah, there's a tiny difference.
So here we have the condition that I must be less than 5. And here we have the condition I must be less or equal to 5. And
so this would be correct if our array would have the size 6.
Exactly.
But we just have 5 elements in there, and therefore we can just access the elements 0 to 4, but not 5.
Yeah.
Okay.
Exactly. And we have one more quiz that we have prepared, if the connection is working. Can you see the question and the answer options on your device? Does it work? No, it's not working? Okay. Then maybe we can ask the question next time at the beginning of the lecture.
So let's skip it for now. I think we,
Oh, okay. We haven't seen this.
Maybe we can cut this out of the recordings then.
And the last topic of today is addresses. We just cover the very basics of addresses today because we have 2 lectures that are dedicated to addresses. So the next and the lecture after that. And we now have already used, for example, the address of operator. So we have already talked about addresses at least a bit. If we now consider the memory here, so we have program code or whatever in the memory, but also some variables here. For example, these are all stored in the memory, represented by binary numbers, so zeros and ones. And what we now want to know is, can we store the address of one, let's say, specific variable, so that we can maybe have another variable that knows, okay, the variable is at position 0xxe8, and maybe even can modify this value. So can we store it? For example, using the address of operator. So we have used it. We know, okay, this receives the address of the variable, so not the actual value, which is in this case 42, but we get this a bit strange output, 0x7ffff. Yeah, quite a large number. And if we use the %p format specifier, we can also print it, and using the address of operator. And the question now is if we can store the address in a variable. And we will answer this question next week.
I think it is a nice cliffhanger for a larger topic for next week.
Yeah, where we will jump into a huge topic in C, the C programming language, which are pointers. All right. Thank you for being here today. If you have any questions, just let us know. You can come to us now if there are any questions. Otherwise, see you again next week, again in lecture hall P1, here in the same room. And yeah, don't forget to work on assignment 1 and the weekly exercises.
Thank you. See you. Bye-bye.